Hi folks, my name is Ashish Kumar Jain and I am here to explain Heron's formula in a video tutorial for the course An Introduction to Interactive Programming in Python by Professor Joe Warren, Scott Rixner, John Greiner, Stephen Wong. So let's begin. So our main agenda will be to see how distance formula is computed between origin to a point and from a point to another point. Then we will move forward to Heron's formula, and then we will write a Python code to compute area of a triangle applying Heron's formula. So let us start with two-dimensional Cartesian coordinates. So here we are seeing two perpendicular axes. The horizontal one is called x-axis and the vertical one is called y-axis. We can imagine them as two perpendicular number lines where numbers on horizontal axis are called x coordinates and number on vertical axis are called y coordinates. The point of intersection of these two perpendicular axes is called origin and it is denoted by 0, 0. So let's see what coordinates of a point mean. So suppose we are given a point P with coordinates x, y. So what this x and what this y mean for a point P in this two-dimensional plane? Let us see that. So the distance of point P from x-axis is its y coordinate. It is obtained by dropping a perpendicular from point P to x-axis. Similarly, distance of point P from y-axis is its x coordinate. It is also obtained by dropping a perpendicular from point P to y-axis. The distance of point P from origin is given as the shortest distance between point P and origin. So this line shows the shortest distance between P and origin. We denote it by, let's say, D. So if we observe carefully, both the angles are 90 degree. So, and these are both perpendicular axes. So the remaining angle of the quadrilateral will again be 90 degree, and hence we are getting a rectangle here. Since we have a rectangle here, this side x and this side will again be x because opposite sides are equal. Similarly, this is y and this is y. Now if we observe carefully, in this right angled triangle, our base is x, our height is y, and hypotenuse is d. So by Pythagoras theorem we can say that d square is equal to x square plus y square. So we can easily obtain d here, which is the distance of a point from origin. Now let us see how we compute the distance between two points. So moving forward from the previous slide, we have point P x1, y1, where what x1 and y1 means, it is clearly denoted in this slide. Now let us introduce another point Q with coordinates x2, y2, where x2 and y2 are depicted clearly what they mean. Now distance between point P and point Q is the shortest distance between them, which is denoted by D. Now if we observe carefully, here this base is equal to x1 minus x2, which is the difference in x coordinates of point P and point Q. Similarly, if we observe this height is the difference in y coordinates of P and Q. Now if we observe carefully, base, height and hypotenuse, these are forming a right triangle. So D is the hypotenuse of a right triangle with base x1 minus x2 and height y1 minus y2. So similarly, applying Pythagoras theorem here also, we can obtain that D square is equal to x1 minus x2 whole square plus y1 minus y2 whole square. So here we can conclude that distance between 2 points D is given as square root of the sum of differences of 2 points x coordinate and y coordinate. Now let's move forward to triangle. Here we have a triangle with vertices A, B and C denoted by coordinates x0, y0, x1, y1, x2, y2 respectively. Now what I have done is I have denoted side A opposite to vertex A, side B opposite to vertex B, side C opposite to vertex C, as done by standard convention in coordinate geometry. So A denotes the length of side BC, B denotes the length of side AC, C denotes the length of side AB. Now here the length is actually the distance between 2 points. The side is denoted as distance between 2 points. So C is actually the distance between point A and B. A is actually distance between point B and C. B is actually distance between point A and C. So from following it from the previous slide and applying Pythagoras theorem and the distance formula that we have seen previously, I can right away say that A square equal to x1 minus x2 whole square plus y1 minus y2 whole square, B square equal to x2 minus x0 whole square plus y2 minus y0 whole square, C square equal to x0 minus x1 whole square plus y0 minus y1 whole square. Now for Heron's formula we require calculation of a semi-parameter. Semi-parameter is defined as sum of all the sides divided by 2. So S here can be computed as A plus B plus C by 2, where A, B and C are already calculated by the distance formula between 2 points. Now let us move forward to the code. Now here, while writing the code, since I have seen that I require square root function, so I will be importing math here. Now let me define a function named triangle area with coordinates of all the 3 points x0, y0, x1, y1, x2, y2. Now let us put a comment here, doc string function okay. Now what we need to do is we have to compute 3 sides of a triangle. So we can randomly compute it, since in that diagram I have denoted sides side A opposite to vertex A, side B opposite to vertex B, side C opposite to vertex C. But here we can randomly compute A, B and C because these are just variable names. What I am doing here is I am right away copying the formula that we have derived previously. Okay, so we got all the three sides of the triangle. Now we have to compute semi-perimeter. We can right away get it as A plus B plus C by 2. Now here a word of caution. Since A, B, C are obtained as a square root of a positive number, it can be a floating point number. So it is better to use 2.0 for a floating point division in S to get accurate results. Now say we define area by variable A and we compute it as S. Okay, closing braces are matching. Okay, this is our area which we require, so I'm returning it. Okay, now let us check our function. Let's say I give three coordinates 0, 0 origin, 3, 0 x-axis, point on x-axis, point on y-axis. So it is a right triangle. We'll see what it will compute to. Another example. Okay. Now let us see whether our function is running correctly. Okay. So now it is computing area in floating point. So let's check our result. Since this is origin, this is point on x-axis and this is point on y-axis, so we can clearly see that it is a right triangle where base is this 3 and height is 4. So if we compute area of right triangle, and if we have seen it in the video and if we remember it, it is given by half into base into height. So by that formula, if we compute the area, it is actually half into 3 into 4, so that is equal to 6. So that way if we check, this result is correct. So our function is correct. So that is what I wanted to introduce here. Actually I found many questions regarding this in the forum, so I picked this point. Hope it is now clear to everybody. Thank you. Have a nice day.